Hey everybody, this video is about how rotating your coordinate axes affects the moment of inertia. So let's say you have some shape and given some coordinates, you'll have some area moments of inertia, Ix, Iy, and then the product of inertia. Okay, so what happens when you rotate the coordinates, say like this, to some other x prime, y prime? Then all of these values change as a function of that angle. Right? These are going to be different from these. Now, if you rotate these coordinates to a very specific orientation, one of these two reaches a maximum value, while simultaneously the other one reaches a minimum value, and this one becomes zero, the product of inertia. And at this specific orientation, we call those principal axes, and these values, this would be the principal moments of inertia. And then if you continue to rotate, this value will start shrinking, this one will start growing, this will become non-zero again, until this then becomes a min, and this one becomes a max, and this one goes back to zero. Okay, so this takes some explaining. First, let's talk about rotating coordinates. So instead of this triangle, well, I mean, you have some shape, but to solve for these, right, it looks like this. For some differential area here that you integrate over the entire area. So let me just focus on that differential area. Okay, it has some position in polar coordinates, r alpha. So in the xy coordinates, Cartesian coordinates, the x component would be r cosine alpha, the y component r sine alpha. Okay, and if we rotate the coordinates, say from x to x prime, from y to y prime, by some angle theta, Now, what are the coordinates in the new rotated x prime, y prime? Right, so here to here is alpha, here to here is theta, so here to here is alpha minus theta. So in the x prime, y prime, the x coordinate would be r cosine of alpha minus theta. Y prime would be r sine alpha minus theta. Then if we do that trig identity where you have cosine of something minus something, that's the one that looks like cosine alpha cosine theta, and then sine alpha sine theta. Let's not forget the r. Okay, and then this trig identity, sine of something minus something, is sine alpha cosine theta minus cosine alpha sine theta. Let's not forget the r. Okay, and then notice, look, r cosine alpha is x. Right, this is x. R sine alpha is y. R sine alpha is y. R cosine alpha is x. So x prime is x cosine theta plus y sine theta. Y prime is y cosine theta minus x sine theta. So that's how coordinates rotate. If I bundle them together in a matrix. It looks like this. Right, so x cosine, y sine, y cosine over here, negative x sine. So this is a rotation matrix. If you have coordinates in this coordinates, xy coordinates, you rotate about the z-axis to get to your x prime, y prime coordinates. And we're discussing this stuff, right? Moments of inertia. So if you want the moment of inertia, Ix, you just do this, right? If you want Iy, this, the product of inertia, like this. But now if we want Ix about the new coordinate, x prime, then we have to take y prime squared dA. Right, so right here, y prime is this one, right here. So that goes here. Right, so if we take a look, let me just write it. Okay, that squared dA. So let's square that. So y squared cosine squared minus 2xy sine cosine plus x squared sine squared dA. Okay, and now let me keep going. So this first term, let me write it like this: cosine squared y squared dA. Now this term right here, minus 2 sine cosine xy dA. And then this last term right here, sine squared x squared dA. Now take a look at this. Y squared dA. Look, that's Ix. Xy dA. Look, that's the product of inertia. X squared dA, Iy. Right, so Ix prime is a function of Ix, Iy, Ixy in the original xy coordinate system. And then you do the same substitution for Iy prime, where you take x prime square dA, where x prime is this. So you put that here, square it, and then you do the same procedure. And then similarly for I, x prime, y prime, x prime, y prime, dA, where x prime and y prime are these, x prime, y prime. And then it simplifies to here, which I just have copied straight out of the book. So this you can just refer to. Now you know where it came from. You can just use it at this point. Now there are some interesting features when you rotate coordinates. I was saying that if you rotate it to some particular orientation, one becomes a max, one becomes a min. How do you find when a function reaches a max or a min? You take the derivative. So this is a function of 2 theta, so I'm just going to take the derivative with respect to 2 theta. Take the derivative and set it equal to 0. Right? That's how you find max or min. So let me just do that for one of these. Okay, so let's take a derivative. 0. And then derivative of cosine minus sine, derivative of sine, cosine. Okay, so that's the derivative. set it equal to 0, and solve for theta. Okay, so set this equal to 0, solve that for theta. So, okay, let me write this over here. Okay, so I left this and then I made that opposite. And then, let's see, I can take cosine and put it over here. And then I can take the reciprocal of this, put it on this side. Okay, and then sine over cosine is tangent. And then there's a minus sign, and then I'll just multiply that through over here. Okay, and then just take arctangent and then divide by 2. So at this particular angle, that is when you have principal axes at this orientation theta p. Now what's interesting is, do the same here. Take the derivative here. Okay, let me just do it quickly. So 0. Derivative of cosine minus sine. Derivative of sine. Cosine. Okay. Set this equal to 0. Solve for theta. What you get is exactly the same angle. That means they both reach max or min at the same orientation. So that's interesting. And furthermore, at this angle, the product of inertia becomes 0. I mean, take a look. Set this equal to 0. Let me move this to the other side. Minus ixy cosine. I'll move cosine on this side. I'll take the reciprocal of this on this side. Right, and then this becomes tangent. And then let me multiply that minus sign through. See? This becomes 0 when these other two become max or min. And then the last bit of information, if you take the second derivative, I'm just going to do it right in place here. Take a second derivative. Let's do the one more derivative. So sine becomes cosine. Cosine becomes negative sine. Okay, and then let's take the second derivative of this one. Second derivative. So then sine becomes cosine. Cosine becomes negative sine. And now, look at this second derivative. Look at this second derivative. They're exactly opposite of each other, which means when one becomes max, the other becomes min. When one becomes min, the other becomes max, just like I stated earlier. Okay, so that's kind of the whole explanation theoretically. So let's get to another video where we apply it. So I'll see you on that video.